Hello everybody, today we're going to be working on limits a little bit more. So I would like you to do the try this, which is finding the limits. So put me on pause and come back and check your answers. Okay, so for number one we have here, find the limit as x approaches -2 of x plus 9 over x squared plus 3. So remember I always said the first thing you should always do when you're finding a limit is try direct substitution. All right, so I'm going to take -2 and plug it in. So we have -2 plus 9 over -2 squared plus 3. So that's 7 over 7, which is 1. So the limit is equal to 1. All right, so let's try number 2. So again, we're going to try direct substitution. It is the limit as x approaches 3 of x minus 3 over x squared minus 9. So I'm going to do the direct substitution. I have 3 minus 3 over 3 squared minus 9. So that's 0 over 9 minus 9, which is 0 over 0. That is undefined. So we have to try doing what we did the 2 days ago, yesterday and 2 days ago, the dividing out technique. So let me get rid of this. So I'm going to factor the numerators, factor the denominator. So we have here x minus 3 cannot be factored. So we have x minus 3 here. X squared minus 9 is x plus 3, x minus 3. So the x minus 3's, they reduce to 1, right? Remember, that's the whole. There's a whole. That means at x equals 3. So I have 1 over x plus 3. So now we rewrite the limit. So it's the limit as x approaches 3 of 1 over x plus 3. All right, so plug the 3 in. Now we can do direct substitution. All right, so I'll do that down here. We have 1 over 3 plus 3. So that's 1 over 6. So the limit is 1/6. All right, so let's take a look at number 3. So again, we're going to try direct substitution. It is the limit as x approaches 9 of the square root of x plus 7 minus 4 over x minus 9. So again, we're going to plug in. So we have the square root of 9 plus 7 minus 4 over 9 minus 9. So I notice right away in the denominator it's undefined. But how do I factor this so that I can reduce it? Well, you can't actually factor this. So we have to have another way to figure out what the limit is. And that's called the rationalizing technique. Okay, so let's just write down. Let me just get rid of this actually. All right, so rationalizing, hopefully remember we did that with radicals and with complex numbers. Rationalizing is multiplying by the conjugate. So rationalizing, so let's write down rationalizing is multiply by the conjugate. So remember, the conjugate is the sign in the middle of the binomial is opposite. So sign in the middle of the binomial is opposite. Okay, so I'm just going to show you to recall what happens when we multiply conjugates together. So you don't need to write this down because I'm just going to put it in the middle of the paper. So let's say I have x plus 4 and the conjugate would be x minus 4. So again, don't write this down. So these are conjugates. Notice the sign in the middle is different. One's plus 4, one's minus 4. So when I double distribute, I get x squared minus 4x plus 4x minus 16. And then notice the middle terms cancel, so I have x squared minus 16. So really when I multiply conjugates, since these two middle terms will always cancel, it's really just taking the first term times the first term and the last term times the last term. And remember, it is always minus, always, okay? So let me just get rid of this. Okay, so let's take a look at how to find the limit by using the rationalizing technique. So the first thing we're going to do is multiply the numerator and the denominator by the conjugate. So take a look at number 1, which is from the do now. We have the limit as x approaches 9 of the square root of x plus 7 minus 4 over x minus 9. Now we're not doing the conjugate of x minus 9. It's the conjugate of the numerator where there's the radical, because that's where we're going to have an issue here. Okay, so that's the piece where we're getting the conjugate. So the conjugate of the square root of x plus 7 minus 4 is the square root of x plus 7 plus 4. And we're going to do that in the numerator and the denominator. Okay? All right, so next thing we're going to do is simplify the numerator. So we're going to double distribute, but remember the middle terms will cancel out. Okay, so we really just have to multiply the first times the first and the last times the last. We're going to keep the denominator in factored form. Okay, that's a key here. All right, so when I multiply the numerators, I'm multiplying the first times the first. So the square root of x plus 7 times the square root of x plus 7. Remember, when you multiply a square root by itself, you just get that number that's underneath, the radicand. So it's x plus 7. Minus, because remember I said when you multiply conjugates, it's always a minus. And then I'm multiplying 4 times 4, which is negative 16. So there's your minus 16 over. Now the denominator you're going to leave as x minus 9 times the square root of x plus 7 plus 4. So remember, we are not multiplying out the denominator. Okay, so now I want to clean up the numerator. So I have x plus 7 minus 16 here. X plus 7 minus 16. So 7 minus 16 is negative 9. So we have here x minus 9 over x minus 9 times the square root of, sorry, I ran out of room here. The square root of x plus 7 plus 4. And then notice what happens here is that the x minus 9 and x minus 9, they reduce to 1 and 1. So then I have here 1 over the square root of x plus 7 plus 4. Okay, so now we just have to rewrite the limit. So I have the limit as x approaches 9 of 1 over the square root of x plus 7 plus 4. Now we're going to do direct substitution and plug in 9. So you could do that on the side over here. So we're going to have 1 over the square root of 9 plus 7 plus 4. So that's 1 over, so 9 plus 7 is 16. So we have the square root of 16 plus 4. The square root of 16 is 4. So we have 4 plus 4 is 1/8. So the limit is 1 over 8. Okay, so let's take a look at number 2. Okay, so I have here the limit I don't know where that red line came from. So I have the limit as x approaches 0 of 1 minus the square root of x plus 1 over x. Okay, so we are going to multiply the numerator and the denominator by the conjugate. So the conjugate of 1 minus the square root of x plus 1. Remember, only changing the sign of the binomial, not what's under the radical. 1 plus the square root of x plus 1. Numerator and denominator. Okay, so we're going to multiply that. So we're going to multiply the numerators. Remember, since they're conjugates, we don't actually have to sit there and double distribute because the middle terms will cancel out. So it's the first term times the first term, which is 1 times 1 is 1. And then it's the last term times the last term. Now remember, it is a minus. Now, since I'm multiplying the square root of x plus 1 here, times the square root of x plus 1. And remember I said when we multiply square roots, we get what's under the radical. Now what's under the radical is a binomial, and we're minusing here. So you have to use parentheses because you are minusing now a binomial. Over, and then remember, leave the denominator factored. X times 1 plus the square root of x plus 1. Okay, so now in the numerator, we have to distribute the negative. So we have 1 minus x minus 1 over x times 1 plus the square root of x plus 1. All right, so now let's clean up the numerator. So I have 1 minus 1 here, right? 1 minus 1 is 0. They cancel each other out. Right, so these cancel. So now I'm left with negative x over x times 1 plus the square root of x plus 1. So then what happens is the x's reduce, but they reduce to negative 1 because there's that negative there. So then I have negative 1 over 1 plus the square root of x plus 1. So now we have to do the limit by doing direct substitution. So we have to rewrite the limit. So we have the limit as x approaches 0 of negative 1 over 1 plus the square root of x plus 1. Now we'll do direct substitution, so you could do that on the side on right below it if you want. So we have negative 1 over 1 plus the square root of 0 plus 1. So it's negative 1 over 1 plus 0 plus 1 is 1, so it's the square root of 1. The square root of 1 is 1, so we have 1 plus 1, so that's negative 1/2. So the limit is equal to negative 1/2. Okay, so that's it, and stay well, stay safe. Have a good day.